Alright, so I'm back. I need to speak. I need to speak softly because everyone's asleep. So that's what were we doing? Oh yeah, we were simplifying this. So yeah, let's learn object-oriented programming. So Qt browser. Don't appear with Haskell. Read this. I already read it. I do not remember a thing. But I do remember some things. So I'll see you later. Alright, hello. So yeah, we were making this and I was about so I learned how to use HUnit. I basically now have a different layout which lets me use HUnit, and don't know what is happening here. Alright, so source and test, in which I have a test suite which I have already written to test some trivial things and also to test the phantomatic not working thing which goes in a loop. Let's make it go in a loop again. Stack test runs the test suite. Oh, there's an error. Yeah, because I am adding a new test right here and it doesn't work yet. So let's make it work by saying, okay, I need to see if this thing is equal to, I don't know, let's just comment it out for now. Let's just do it for now. Alright, as you can see, error in parse P5 trivial scenario, which is what I did in the last episode, and there's a loop. Okay, so let's see. So I was testing getNum, and but to do it, I figured that I might upgrade the parser first, because I am using these things to chain maybes together, the monad chaining operators, which we wrote as an exercise, and it is getting cumbersome. So I might first write the monad chaining operators for the parser type, and then I will do this. So I might do it before I write the test, but let's see if I can write the test first. So I might ignore the number, or let's not ignore it, let's call it number 1 and let's return it. So okay, let's go on. This chaining will become even easier once we implement what I said. So let's getNum, chain it to another getNum, and let's just copy it, do it again. So yeah, of course this will be input, and we will have all the numbers at the end. So we now need to compare the result to the thing, and of course this will be everything. We need to compare this to basically the result that we expect, which is just, well, nothing for now. Let's give it to a function that takes the, oh, there already is a function, so right here, and let's do something with it. Let's actually, I forgot to, should be like this. Oh, it should be like this thing here. Alright, so let's just let's just do it like that, and yeah. Yeah, seems to be okay. So let's just say that I need to, yeah, let's return something. Let's return the numbers in the tuple, or triple, however you want to call it. So is this the right, yes, it's the right one. And right here, let's actually just compare it to the tuple that it should produce. But of course it's just value, and it is it contains the rest of the things should just be an empty string. So that's that. We compare it, and that should work. Let's try to format it, and it does. So yeah, I don't think we need this, but I will keep it just as a safety net. Okay, so let's run the tests again. Right, there's an error. So current match type. Oh, okay, this is a weird way of writing that. First time I saw it, but maybe. So I expected maybe end, and got this. So this is at here as the second argument of this. Oh yeah, we need to return a maybe. Okay, so like so. What now? Oh, okay. Yeah, of course. I don't actually need to. So we can just ignore the last input, and it doesn't return this. It returns just the tuple. So like this, and that's actually all we need. And I hope like that it will not complain about the. It does. Yeah, but it should be a maybe. It should be a maybe, because these are chaining operators for the maybe value, so it returns a maybe, which is, it's okay. We could even use return here, if I am not mistaken, which is another monad thing. Yes, we can. Okay. What if we use it here? And I'm just getting a little bit off track, but it's interesting if we can do these things. Yeah, we can. All right. But I want it to be just so. Okay, so let's see what the error was. It's the same thing, really. So still got the loop, all right, and we got another failure, which is two space separated numbers, and we got nothing. We got nothing because we forgot to skip spaces. So let's feed this to number one, and once we get number one, and once it skips spaces, feed it to skip spaces. This needs to be given input. This is very cumbersome, as you can see. So before I do this, let me implement a better parser. So let me implement a better parser, and to do this, let's here. So we will have a parser type, which is separate from the greymap type. So parser library is here, and will have the greymap library. Yeah, let's just greymap data types. I'm organizing it a little bit. So parse library goes here, basically. And oh, okay. So let's have something here to do the parser type. So I don't remember this much, but that's the fun part. So it's going to be a type class, and it's going to be just a type class. So let's see. I'm going to make it accept something. Let's have a parse result, which is a structure. Well, yeah, I have to remember that I am not using Rust anymore. So yeah, what is this? It's not even that. I think we can just use a type alias, and it will be just maybe with a byte string here, and and we will have, of course, arbitrary thing, which is our result. So this is the parse result, while the parser can it also be a type? Something that returns a parse result and takes in a byte string, returns a parse result. Type A. Yeah, that seems right. Yeah, but let's actually make a data type which is a record. I wrote browser. Yeah, nice. I was trying to use fancy Vim stuff and I failed. So parser, byte string, let's see. It's a parser and it has things. If I remember correctly, this is much more like it. Oh, that's beautiful. Beautiful formatting. Okay. So it doesn't do things I really like, but it works to a degree. So yeah, I guess that's it. So the parser is just something that has a function here. So I can basically now I can basically wrap functions inside of parsers. So, and why would I do something like this? Because now I can implement operators for parsers. So let's begin with this this one, which will take a parser and and it will take so we'll take a parser of type A and it will return something which is a parser. Well, now what do we want it to do? We want it to take a parser like, I don't know, parse a number. We want it to also have a lambda here, which will have, the number and the freaking input. And well, do we want to specify the input? No, actually, no. Why doesn't delete surround work? Oh well. So number, and which is basically the result of the parse, and we want, well, let's keep it real. So number, and we want to return something here, which is a parsing result. But we want to be able to just say, okay, so just parse a freaking number, and now we have the number. So now I just need you to, to parse a freaking, to skip spaces, and okay, and then we want to completely ignore the spaces we skipped because it's going to be empty anyways, and then we want to parse another number. Yeah, this is how we want it to be. So this monad filling, of course it's going to be like another number, so let's model it after this thing here, and at the end of it, what do we want at the end of it? Oh, we want to return something which is just what we want to return, which is also needs to be a parser, so it's going to be the identity parser. And it's going to be, of course, wanted to return something, so the identity parser will basically just return, and we can call it return if we want to, because it's going to be basically our return, and then we can do something like this. So classic monad parser logic. I'm new to it, this is why I'm doing the project. So let's parameterize all of this. Well, let's comment this. So let's comment this. Let's comment this, and let's do this. Alright, so parse number, and you know, what am I doing? So it's going to have a parser, which is this, and then it's going to accept a function which takes the output of the parser, which is just the parse result of type A, and it's going to give out, well, not even the parse result, just A, and it is going to give out another parser of type B, and and it will return, what will it return? Well, it will return a new parser of type B. Yes, alright, so let's implement this thing. So like parser 1, parser 2, and okay, it's not really a parser, it's like a function or something. So I first run the parser, and the result of the parser, so I basically do parse on parser, and yes, I need to return a parser. That's something I need to. So parser is what will be returned, and that parser will basically take its input and use the first parser to parse that input. That was the brusquest, if that's even a word, interruption yet. So yeah, let's get back to it. What even is this? Oh, wrong chapter. Alright, so yeah, we were here. I get to become in the zone again, so get into zone again, so do parse. Yeah, so I basically use the first parser on the input, and I get a maybe back, and that maybe can be repurposed, because I get a maybe here. So let's make this clear. Well, I think that's a bit unnecessary. This might be, or it might not be. Yeah, let's just try it out. So get a maybe back, which I basically, I think this is necessary. So get a maybe back from this, which I then feed to a function, which gets its function. What if it returns nothing? Well, then that will return nothing. Yeah. So the maybe will be fed here, and we'll have a parse result. of which I will have two things, one of which I will ignore, the other of which I am very disturbed by the fact that my surround plugin stopped working, but whatever. So I ignore the first thing. Second thing is just input. And I might not need this, but I can't. Oh, now you work. Okay. Yeah, I think it's a little. Yeah, I think it's like this. And get this. So now, yeah, I might want this. So the output of the parser will be this, and it will be used by the parser generator, which will take it and will generate a little parser, which will be used by our parse. Well, we need to return a parser, so yeah, basically just this. Let's format this thing, and let's check if it works. Fast, it's just like a simple example. I should really just use stack build. No, it's the same thing, but at least I can. Well, in principle. So, yeah. So it doesn't like it. It doesn't like this. Yeah, it says that it is ambiguous, but I really want this to have it also for those, but yeah, I guess you can't do operator overloading in Haskell. So we will use a different thing. Let's call it, how about this? Is this possible? Well, of course we need the monad operator here to work with maybes. Okay, the parser type, yeah, classic. Man, that was very prevalent. Okay, so byte string is not there. Yeah, that's because we need to specify the library from which it comes from. Okay, I guess that's all of them. Parse gen. Perhaps you mean parser gen. Yes, I do. Couldn't match type parser with maybe. Okay, so it gets a maybe. Because the output is, well, it shouldn't be a maybe. Expected type maybe B, but we have a parser B. Oh yeah, because it's the return value of this, it should be a maybe. Yeah. So yeah, this brings up the question, what if this returns nothing? Which it could, you know. It really could return nothing. Then it will return a parser that returns nothing. But it, you know, the parser Ch10 can work on a value, yeah, which we need to extract. But what if it returns nothing? Well, then we need to return a parser that returns nothing. So basically an identity parser. So let's actually handle this in a more verbose manner to just understand this better. So we do the parse and let's match it. So in case we have, you know, just of this form, then we do something. The nothing case intrigued me. I think we need the identity parser with nothing. That's what I think we need, but we will see. And in case we have something, then we use the output and we use it against parser gen. And what about the input here? Well, we can ignore it because parser gen will basically be used on, well, but it needs to be used on that input. But we need to return a parser, and this already returns a parser. So yeah, it's weird that we are ignoring the input. Perhaps we need a way to advance the input, which is not consumed. Yeah, because right here, as you can see, we did not worry about the input. It is basically just like automatically brought forward. So right here, I think I might have to figure this one out before I go on. I figured it out, maybe. Yeah, it's okay like this because it still returns a parser as this is a parser. So this will now return and maybe value, and this makes it clearer that we just need this. So but in, in just in case it doesn't work, let's keep it like this for now. So let's see. All right, clear match type by string parser. So textual type parser B. Yeah, this is a parse string parser. Yeah, I should return a parse result B. The function parser, this is here, so it doesn't like this return value. The function parse gen is applied to 2 arguments, but its type A parser B is only 1. Oh, yeah, I get it. We need to activate the parser by using the parse, and it works. So let's write a little test. To test this out. So it's going to be here, and it's going to be the, yeah, we need a new nomenclature. So mash header version is there, parse p5 get now. Let's test this thing, which we will call the end then. And we could make it a function if we wanted to, but I really want to test it as, because ideally I want to make it into a monad, but I think it does not, that it doesn't do it, he doesn't do it in this chapter, so I will not turn it into the actual, there is a class mode, I will not use that thing now. So alright, so yeah, let's just call it as it is, and let's do it. Just copy this and call it just, yeah, same thing. As a matter of fact, I will not even have a dedicated section. I will just use it in conjunction with get them. I am aware that it is not a unit test. I also do not care. So right now we can just do it like this. So we can construct a new parser. Which gets a num, skips spaces, and gets another num. It's not that simple though, we need to do it like this. And we also need to put one useless one here, which will be, we will make it go away eventually, but for now. And I hope it works without parentheses, but to avoid confusion, let's put them anyways. So like this, and this lambda needs them. Basically every time I create a lambda, parentheses. This is the last one in which I get the last number, and I save it here. So number 2. 2 is better. I don't know, I wanted the same, the loneliest number, but I failed. So number 2. Now we can just return 1. That's what I would do if we had the return operator, but we don't. So yeah, our goal is to return a parser. So we might be needing the identity parser. Finally. Yeah, so the identity parser will just allow us to do things such as return these. Yeah, and because this function needs to return a parser. So we can't just return this, we need to return a parser, and the identity parser is just when we want to return this, but we can't. So yeah, just put the parser there, and now you're good. So in a way they're not explaining anything, but that's fine, who needs explanations? So yeah, I don't know what my brain did there. So it's like this. This goes where the actual is, which is here, and the expected of this operation is nothing because we haven't used the parse. So let's actually use it. So we construct the parser, and then we use it, and we use it to into parse. Let's give it like a more descriptive name on an input, which would be 2 numbers, 1, 2. And we will see if this compares to our input here, our output here of a tuple, basically. But also it needs to return, of course, since it will return, well, it won't really. Well, it will, because it could fail. So like this, and there you go. Okay, let's format this thing. Oh, that's so ugly. Okay, let's build it. Yeah, we don't need to build it. So we need to test it. There you go. So, yeah, 8 parser we haven't implemented yet. Let's do it now. So, I think it's a nice thing for it to be the first parser here. So it's a parser, you know, like this, but really it just takes anything. Well, no, it takes a byte string because it's a parser, and it returns anything you throw at it. And it's really a parser constructor because it returns a parser by giving it this and this anything, which it will gladly return, you know. Yeah, and so the it parser, what will it do? What will it do? It will take an input and the value, it's input, and it will just freaking return value. The input, it will build a basic parse result. That's pretty much all of it. Yeah. So now we have the identity parser. Let's see. Okay, why doesn't it work? Expected type and it returns maybe. Yeah, I don't know why there are two of those. Shouldn't be one. There you go. So it doesn't like num1. I think because I forgot to call it like that, yeah. Alright, it parser has this value here. So what could a match parser be with actual type? Oh, we need to wrap it. That's actually pretty inconvenient, so let's actually automatically wrap it ourselves by returning a freaking parser. Of type A. No, yeah, not of type A, of type yeah. And let's see. Let's see. Can't we leave it like this? That would be intriguing. No, we can't. So a parser, which, you know, takes an input and returns this. That's pretty much all we need to do. Don't even know if that's necessary. Let's try to build it. Right, seems to be working. Let's see. Let's get it working and then let's try to open the thing. Okay, so same problem. But it's about getting them. Yeah, we need to wrap that up. You know what? We could actually turn all of these into such abominations. Let's see if there would Haskell. Let's see what he did. Let's see what he did. So, like Vietnam. We called it Vietnat. So here's the beginning version. Let's see, like later on he uses it as if it was yeah, but it still uses this as a that's intriguing. So how is he able to do that? Well, does he use a new type? He does. Ooh. So instead of using data, we can use a new type, which lets us do such magical things. But I don't think it's still. Oh, well, let's try out. Does it still complain? Yes, it does. So yeah, it doesn't eliminate our problem. It just makes it more efficient, I think. So here's the identity parser. Oh, spoilers. Is the parse function. Don't know what that does. So yeah, for instance, here it becomes okay. It also makes sense because it's like types become way easier to write down. So yeah, this changes a lot of things. So let's do the refactoring again. So parser. Okay, no, still a parser of nothing, no, int. What about, what was it, int? Yeah. What about this? I might create a macro. Yeah, let's create a macro, even though I like, there are like 2 functions left, well 3. Yeah, let's just create a macro. Alright, macro, which until the parentheses it writes parser. And well, does that int? No, it really shouldn't. So start the macro again until the parentheses, it substitutes it with parser. It then removes the parentheses, goes until the comma and erases everything. That should be good. Let's try it out. Beautiful. Alright. The power of Vim. Yeah, that's pretty much all the refactoring we need, I think. Okay, but that's not all the refactoring we need, because this now no longer works, because we would have to add to parse like here. So let's do this for now, and I don't care about. Let's keep its definition. So. Let's keep, let's keep it. And right, a lot of refactoring. Let's see if there are errors. Yeah, in fact, let's actually just be able to tell it compiles. Okay, so it's good because you can just go until you see the giant chunk of text, and then so parser, what time is it? Okay, alright, goodbye everyone. Alright, we're back. Let's go. Yeah, I fixed a little thing with the terminal, so now I can just, do things. You might want to see my video about that. Let's now go to the freaking... Yeah. Okay, so let's go. So here's the free project. Just gonna stack build and see if it works. It doesn't, of course it doesn't. Otherwise we won't be here. So current match expected type. Where is this? 50. I really need to have a nicer developer environment. So yeah. There's only one what? Don't tell me that it's like, come on, man. That is bullshit. Alright, shouldn't swear. So, here we go, parser. With actual type. Oh. So I need to make this a parser. Alright, so I guess I could just say, yeah, give me the version, and I will make a freaking parser, which is a parser, and of course there will be dollar signs, because this is Haskell. So make a parser and give it that lambda right there. And I don't know if guards work with lambda, so for now I'm just going to use the if then statement. So if is a prefix, do this, otherwise just do that one. And that's it. Let's see if it formats. It doesn't, because we need to see parser error. Right, it's the equal sign. In what line? 56. Yeah, of course. Then, well, else otherwise then. Perfect. Okay, so now it should return a parser. Let's see. I don't know why I am in this layout. So let's see. If you're interested, I'm using Xmonad as my window manager. Alright, so L8 is prefix of 2 parse. Oh, yeah, I called it input, didn't I? Which is less descriptive of 2 parse. Yeah, 2 parse, I guess it's like cringe. I don't know. I don't know how to name things. Perhaps you meant input. Of course I meant input. This is like
C++ muscle memory. Alright, so here we are. Parser of int couldn't match type with this. Yeah, the same thing. So there's a little insect flying around, being happy. Go little insect. Alright, so getting back on that. Yeah, such as this. Let's do the same thing. Alright, so I guess that's it. I just need to know why like this, different ways of calling this everywhere. Yeah, at this point it is going automatically. Alright, skip spaces. Skip spaces. I could have done it in another way, which would have been interesting. You know what? I will try to do it that way. And since I'm not managing Git correctly, I haven't made a commit in ages. It's not even a Git, but yeah, that's how I like Git. No Git. That's how I like my Git. Supposed to be a joke about coffee. I have probably failed. So I have now made parsers work like this, but you know what? I guess it's fine if they work like this. I wanted to do something like I did in Rust, which you wouldn't understand. So not because you're stupid, just because I can't explain it right now because I do not want to. I do what I want to. Because I'm a free man. Alright, so right now let's start build. Why are you not rendering my words? Yeah, start build. So yeah, errors. Sure, love errors. Oh yeah, of course. Because it takes an amount. So it actually takes something in. What the hell is amount? I don't know. It's a number, right? Is it an integer? I feel like using an integer isn't necessary. Because it's like a size value. They won't go over much. But who cares? Integer, yes. Alright, so it doesn't like it that for some reason. Maybe because like the types are fruct. The cussing was well hidden, I guess. So yeah, I shouldn't have an argument. It should have, because it's a parser. So right now I'm using parse p5, which it doesn't work because it's a parser. But I can, make it work as a fake parser by using do parse. Sure, love $signs. Yeah, let's see if it works. Alright. Yeah, maybe, well, let's see if, what about this? I know parentheses are unnecessary, but I want to have them. They comfort me. And they also make the program work, but let's try without, just for curiosity. It still works. Okay, so now I don't even know why I activated the HCI. I still need to rewrite it, and I completely forgot anything about my being and my purpose in life. So what was I doing before this refactor? I was, I guess I was doing stuff. Yeah, I'm thinking, I'm loading neurons. So I guess now I have all the parser framework all done. Like, so now I can do things such as make custom operators, which I did make, to enable me to make this. Oh, that's what, yeah, because I was writing tests and I wanted to have ergonomic operators, and that's the cost. So do I need to rewrite parse p5? Yeah, because I am testing things. But I think I was testing like more trivial things. Yeah, you understand me, Vim. Here you go. So I am testing two space separated numbers. And to do that, I will test them using the new operators, which are already in place for some reason, which is beyond me. But now it should work. This thing should work. Let's see if it works by testing it. Literally. Of course it doesn't. Alright, so num1 is done in scope. Maybe because I haven't called it like that. Well, no, I have called it num1. Oh, yes, this is why. So, yeah, what even is num1? It's 1. I have written it. Alright, and 2. Okay, errors are always where you least expect them. I was expecting this code to fail. So, he doesn't like that. In the second argument, alright, so because he wanted, because he wants a, yeah, I get this, I get you, bro, I get you. I guess I have L, yeah, I do have L, alright, go back, with Vim magic. Yes, same reason, I'm working with byte strings, so I need to use byte strings, duh. Using L8 so that it backs them appropriately. Here we go, parse p5. Yeah, all the complicated errors coming out. So, match header version. Where the hell do I use match header version? Oh, I guess I tested. Yeah, I need to fix all my tests. It won't be that hard, I guess. Just wrap this in do parse. And we're good to go. We're good to go. Do the same thing here. Just wrap this all up inside. So surround till you find a close parenthesis with a function which is called 2 bars space noise. You know, if this is not the best use of parentheses, I guess. So yes, also parse p5 needs a do parse, and parse p5 doesn't take anything. So yeah, but I still need to pass it like this. Oh, yeah, because it returns a lambda, so I think it needs parentheses. I will just put them in case. And the trivial scenario incomplete file also needs a do parse. Yes, I could have used surround. I don't care. Let's format this bad boy. Didn't do anything. Cool. Let's try it again. Yeah. Errors. Woo! Couldn't match expected type with that type with actual type. And skip spaces is applied to one argument. Where is this? Skip spaces is applied to input, but that's because skip spaces isn't a parser. So I guess it's like I'm using the old way of chaining parsers somewhere. There you go. So I will exploit this to easily compose. So compose the parser. Alright, that means I need to do the pause. And I will write this first. Alright, so composed parser will be a parser, and it will be the composition of match header version, and this is the composition operator. I will compose this with, I ignore the value provided by the lambda, and I basically just return the parser which needs to be composed, which is the skip spaces parser, and this will be in this little thing, which will basically just, well, I still need to, let me borrow this, yank around parentheses, paste, Vim, come on, and you bro, work with me. Okay, so this should work, and right, so I don't need this anymore. I do need this because I need to do parse on with the composed parser on this thing. So just like, you know, access the freaking function inside the composed parser and use it on this, and then which I could, well, I don't want to, I wanted to use the $sign, but I'm not sure if I can operator precedence at all. So I don't need this anymore. I don't need any of that thing, well, until the tilde, because the tilde compares this expression with this, which is still valid. Let's format this. Beautiful. You really can't understand what it is compared to. This is what drives me mad about the auto format and this way of testing stuff. I guess this is the last time I will test things like this. It has its weird beauty, but it's completely incomprehensible. Alright, so let's stack test. Oh, it compiled. Was not expecting that. Alright, welcome to programming, gentlemen. So trivial scenario, preluded and defined. Trivial scenario in the parse P5, it didn't work because there is an error, and also the incomplete file, a trivial scenario. Right. It's the same test. That is weird. Oh well, what is the error? Undefined. Oh, yeah, that's very much it. That means that the composition worked because this test did not fail. Ah, so happy about that. Okay. So we now need to implement the parse v5 again. But first I will get Vim working, and first I will, you know, sleep a bit. So see you after I slept. Mama. Didn't mean to make you cry. If I'm not back again this time tomorrow. Okay. Alright. Yeah, we need to implement the thing. So, let's actually do this. Just need to implement it. So it's the same thing, and I guess we could just exploit the fact that it's the same thing. That was fishy. I know there are bindings for managing paragraphs, but they are so hard to press. So, it's basically the same thing. But it's going to be encapsulated in a parser. Okay, we could leave it at that. That's the fact of it. So, we don't need to specify input. We just need to chain these. So, just chain these. That was wrong in so many ways. You know what? Before we do this, let's actually let's try something out. So right here we have want to be able to do it like this, but you know, not here, because here I think I need it. No, I do not need it. That's the thing. I do not need to specify an empty lambda, so well, I shouldn't need to. So like right here, I could just skip spaces, put this with this, and just go on. Let's see what this is. Yeah, this works out. So I should be able to do this, but of course I would need a different operator that does not accept the lambda as a second argument, but accepts a simple parser. Let's write that. So of course it will be where the first operator is, but it will have to go here, and it will have to be right differently. All of these are already defined, of course, I just want to do it for exercise. There you go. Takes a parser A and a parser B and returns a parser B. Yeah, it just has to, I guess we could just exploit the other operator. Just do it like this. Imagination. That's it, pretty much. And to test it, I already basically tested it because I modified the test. So he doesn't like that. Yeah, because it takes an argument. Yeah, because A, well, it wants an A any type, and I've given it the empty, the void, or not void, unit. So yeah, C should implement it as a function of nothing. Yeah, because it could be anything, so let's just ignore it. That worked. And the errors are about other things, so I am proud to inform you that it worked. So right now we could go on, and let's go on. Alright, so let's use the wondrous operator I created to say that we just need to skip spaces and we don't need to keep the output of our match header. We also do not need to keep the output of skip spaces. But we do need to keep the number we match. So let's just keep it inside width. But the wondrous thing here is that we can't use beam surround for some reason, and we can just use width, just all we really are interested in. So okay, then we skip spaces and we don't care about the input. Then we get the number. We do care about the input. So and still why does it not detect? Oh, I get it. Why? Because it thinks that this is escape. Oh, I get you now. He said as he proceeded to do something very inefficient. Then you skip spaces. Then you get the number. You get the idea. But it's not the height. It's the max, degree max. And you check it if it is you get the bytes and the input, and this is actually interesting. So you actually check it, check gray max, and in case it is we need to return a parser. Now we can return a maybe, so we basically return the identity parser with nothing, so that it's a parser that doesn't consume anything, it just returns nothing. In other, we could return, it uses another function called bail, which also produces a parser, and you can give an error here. We will implement that, but for now we will be content with our int parser nothing. So if it does work, we return the get bytes parser, and then we chain that parser which we have returned, we chain it to, by ignoring the input, because we want to ignore one byte for some reason I don't understand. Then we skip the spaces again, and of course we do not care about the spaces anymore. All of that thing is, substituted with this. That's just good design. Then you get bytes. We just need the parser, we don't need to pass it input. So you get the bytes, and you do this. Do you need the bytes? Yes, you do. So here are your bytes, and then you put them to use. But I am not using them right now, so for some reason, just this, yeah. about the rest value? You don't care about the rest value because the framework we constructed takes care of that for us. So we just need to return something. So we return a parser, which basically gets the bytes and returns the green map, which we need to wrap with each parser. That's pretty much it, yeah. So let's see if it formats it. It does. It formats it in a way that is not very good, but you can still understand it. You match the headers, skip the spaces, get the number, put it in width. I don't know why there's an input here. Shouldn't be there. Okay. Get a number, put it in width. Get another, put it in height. Get another, put it in gray masks. If gray max is greater than 255, then just use the identity parser returning nothing. Otherwise get the bytes. And this is actually very weird because it will return nothing, but it will return it as the parser element. That's just weird. Yeah, I guess we need to write bail right now. It will accept an error in the future, but not right now. So yeah, then bail. Else get bytes. Get one byte, ignore it, and call on skip spaces. Get bytes. Yeah, that's it. And then at the end, take the bytes which we will use in the future and return the identity parser. We could use another thing here, which is a functor, instead of using this operator, which would enable us to not use it parser. A little bit simpler, not that much, but we will do it in the future. So let us write the bail parser. I will write it just below the identity parser because I feel it's similar in the spirit. I will then go to bed because I am so tired right now. So, does it take an A? No. Does it return a parser? Yes. Maybe. Well, it needs to. Yeah. So what does it do? Well, it returns a parser that fails. So what is a parser that fails? Well, a parser, as you all know, returns parse result. Our parser right here will return nothing. It will be a function that accepts an input, ignores it, and returns nothing. That's pretty much it. So why am I needing to say A there? Well, I don't really need to say A, but it has to be something. So I might be able to do this. I don't know if I can do that. So I will keep it A for now. Maybe the linter will work. So, parse P5, type signatures. There are multiple declarations because I haven't. I hate it when it does that. It fools me into thinking that I really jumped there. Oh, those are the juiciers we want. So, given match parser gray map with maybe gray map. Okay. In the expression. So it's in the match header. Yeah, it's in the parse P5 which we have written. And I guess the match header version. So what is the final expression? The expression input match header version. Oh yeah, I do not need to wrap this in a lambda. I just need to do it like this. Okay. Still got an error here, so let's see. With actual type, possible cause. Alrighty. Yeah, I do want to return a parser gray map, but I think... So let's see if parentheses is the issue. I don't think it is here, but I will do it anyways. What about for all the lambdas? Let's put parentheses in all the lambdas. This will be painful. Yeah, but you know what? In the book, I think he does not put parentheses in all the lambdas. And also, let's see if like it was because of... I did not think it's because of that. Yeah, same exact error. Okay, so let's go to the book. To the book. And let's see. There it is. Oh, my eyes do not work at that. So, it does not do that. Because if we go down until, you know, you come to the same things he does, we're doing it. So this is like the shitty implementation. There you are. Now that's the maybe monad implementation. We need to look at the final implementation. Right here, he even like uses, oh no, that's just an example to showcase. This is how he implemented it. I do not know how he did it. He also uses functors before he does anything else, which I will need to look into. As you can see here, he, no idea what this is, still he doesn't use parentheses, which means that this thing stays here. So basically this operator is applied to this lambda, to all of this lambda. So I want to see if we specify the particular precedence for that to work, because my fear is that, so here's the definition. It doesn't seem to use any particular precedence specification, so I think this might be powerful enough to not need such things. So our error has to do with something else. Let's see. He says that this is applied to too many arguments. In the second argument, namely this, in the expression, same thing, basically. So, let's see. Let's find out why this doesn't work. So, too many arguments. How is that even possible? It's a binary operator, so yeah, because the expected type was to have a function. Oh, I am wrapping it in a parser, even though it's already a parser. Yeah, that was stupid. That's cool. Okay, so width and height, it doesn't like it. Can match expected type integer with actual type int. So I have conflicting. Yeah, I think I used an integer where I wanted to use an int. Oh, there you go. Yeah, we have one minus error. Oh my god, that's a very big insect. I saw all my life flash before my eyes. Alright, so trivial scenario. Yeah, and we're back at square one. Here you go, with a loop. But now we are equipped to find out why the loop is happening, because we have a more intuitive interface to chain parsers, and we'll become even more intuitive. Like this is already like much better than it was before. This very shorter, much more intuitive than this thing up here, which we will burn to the ground, and it will become even better as we go on. So this is it for today. I hope you gained something from this.